Greetings, my name is Jean-Michel Pierre-Louis, and today I will be presenting on the structural behavior of two-way slabs and their failure mechanisms. Reinforced concrete slabs are flat, usually horizontal, and of constant thickness structural members designed to be used as useful surfaces or living spaces such as floors and roofs. Reinforced concrete slabs can be divided into elevated slabs and slab on grades. Elevated slabs are usually used as floors and other useful surfaces or spaces. They are usually supported by beams, walls, or columns and exhibit one-way or two-way structural action. Slab on grade are usually used for foundations, highways, warehouses, or airport runways. They are cast directly on the floor and are usually supported by compacted layers of gravel or crushed stones. Elevated slabs are divided into one-way slabs and two-way slabs, which will be the focus of this presentation. One-way slabs are reinforced concrete slab for which the ratio of the length to the width is greater or equal to 2. These slabs are usually supported on only two of their opposite sides, usually the longest sides, and will exhibit one-way structural behavior, which involves the presence of bending moments only in the direction normal to the supported sides. Two-way slabs, which are the focus of this presentation, are reinforced concrete slabs that are supported by beams on all sides or are supported directly by columns. These slabs will exhibit two-way structural behavior, which involves the presence of bending moments in the direction normal to both their widths and their lengths. The different types of two-way slabs includes slabs that are supported by beams on all sides, waffle slabs, flat slabs, and flat plates, on which we will focus during this presentation. Flat plates are slabs that are supported directly by columns. Some of the advantages of using flat plates includes the absence of beams, reduced construction time, reduced construction costs, reduced slab thickness, and building height. Some of the disadvantages of using flat plates includes, most importantly, the possibility of sudden brittle failure at the slab column connection, which is called punching shear. Flat plates will fail by either punching shear or extensive yielding of the flexural steel. The failure mechanism of flat plates is heavily controlled by the flexural reinforcement ratio. A relatively low reinforcement ratio will lead to a ductile failure, the formation of straight line cracks parallel to the column lines. The structure will fail first in flexure. There will be extensive yielding of the flexural reinforcement followed by punching shear failure. A relatively high reinforcement ratio will lead to a brittle sudden failure, the formation of closely spaced radial cracks or fin-like cracks. Punching shear failure or two-way shear will control for a relatively high reinforcement ratio. Also, flat plates with a relatively high reinforcement ratio will fail at a much higher loading. On this slide is shown the crack patterns associated with a low reinforcement ratio and a flexural failure, and the crack patterns associated with a high reinforcement ratio and a punching shear failure. On this slide is a plot of shear force versus deflection for slab column joint test specimens with the same dimensions and different reinforcement ratios, and where the number next to the number 13 is the reinforcement ratio. For example, for specimen S13-028, the reinforcement ratio is 0.28%. We can see from the plot that the specimen with the lower reinforcement ratio were more ductile, and that the failure mode became more brittle as the reinforcement ratio increased. Specimen S13-090 and S13-143 failed by punching shear. We also see that the strength increased as the reinforcement ratio increased. Punching shear is a local two-way shear failure due to a concentrated force punching through the slab, usually due to the column reaction on the slab. It involves the formation of cracks with an angle of inclination varying between approximately 20 and 45 degrees. A pyramid-shaped failure surface around the column extending through the thickness of the slab. Punching shear is a very dangerous, brittle type of failure that should be predicted accurately. ACI 31819 allows the concrete punching shear strength to be taken as the smallest of those three following equations, where lambda s is the size effect factor and can be calculated as shown. Alpha s can be taken as 40 for interior columns, 30 for edge columns, and 20 for corner columns. And b is a ratio of long to short side of columns for rectangular sections, concentrated load or reaction area. And b sub 0 is the perimeter along the critical section. When the concrete punching shear strength is not enough to withstand the applied shear stresses, punching shear reinforcement might need to be added. Different types of through thickness reinforcement includes deformed stirrups, embedded steel sections, lattice type steel reinforcing members, and headed steel studs, which are the most common and most used type. Headed steel studs can be placed in a cruciform pattern oriented towards the orthogonal grid of the slab's longitudinal reinforcement, which is the North American standard. Or they can be distributed radially throughout the slab column region, and that is the European standard. On this slide is a table showing the results of a study on the performance of 6 large-scale flat plate slab column connection specimens with different headed stud layouts. On this table, C refers to the control specimen without shear reinforcement, and O and R to the specimen with the orthogonal and radial layouts respectively. The number after the letter is the reinforcement ratio. We can see from the table that for the same reinforcement ratio, the specimen with headed stud reinforcement had a much greater capacity. We also see that the difference in increased capacity between the orthogonal and radial layouts are minimal. Other alternative slab column joint strengthening methods include the use of high-strength concrete and the use of glass fiber reinforced polymer headed studs or glass fiber reinforced polymer corrugated bars. Studies have shown that the use of high-strength concrete will increase the punching shear capacity and increase the cracking load. The use of glass fiber reinforced polymer headed studs or glass fiber reinforced polymer corrugated bars as punching shear reinforcement will help control shear crack size and propagation, increase ductility, and increase the overall punching capacity of the slab column joint. We understand that punching shear failure will control the design of two-way flat plates, and that the reinforcement ratio is one of the most important parameters controlling the failure mode of flat plates. Flat plates should be slightly under-reinforced in flexure to allow deflections that could provide warning against impending failure. Lastly, headed shear studs are the most understood and efficient way of providing direct punching shear reinforcement. Thank you very much for watching this presentation.